In section 1.5, 0 and negative exponents, we're going to first go over what happens if your exponent is 0. And then we're going to go over what happens if your exponents are negative. So the objective, students will understand 0 and negative exponents. Students will simplify expressions involving 0 and negative exponents. Down the road, for you to get better at math, you have to also know how to translate this on your own. But it's saying that when a is to the 0 power, remember, a means a number that you don't know. But when a is to the 0 power, it equals 1. Understand that you don't know what a is, yet the answer is still 1. That's because any number to the 0 power is 1. So right now with your calculator, go ahead, pick any number you want. 5.2374, and then remember, caret top, that means exponent, 0, and you'll get 1. Make up another number. Decimals, fractions, negative numbers, it doesn't matter, it will always equal 1. Just one little catch. If you do a fraction or a negative, you have to include the parentheses. So like if you did negative 6 to the 0 power, you will get 1. If you do 2/3, but with parentheses to the 0 power, you will get 1. Because without parentheses, the calculator doesn't understand that you want the 0 to go to both symbols. I want the 0 to go to the 6 and the negative. I want the 0 to go to the 2 and the 3. And that's why I need parentheses. Any number you come up with is going to be 1. Any number to the 0 power is going to be 1. That's why even x, even a number that I don't know, if I do it to the 0 power though, it's going to be 1. Even pi. Pi is an irrational number. It's a number that goes on forever and ever and ever. It doesn't stop talking. Think of your friend who's irrational. They're just talking, blah, 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 blah. That's like pi. Pi is a number that goes on forever and ever. It doesn't stop. No patterns either, right? Just random numbers, nonstop. If you do pi to the 0 power, this will equal 1. So any number to the 0 power equals 1, besides, and they do tell you this, besides when a equals 0. So what they're trying to say there is, if you do 0 to the 0 power, that will not equal 1. You would actually get an error. So if you did 0 to the 0 power, you get a math error. So just keep that in mind. So any other number besides 0 to the 0 power is 1. So 7 to the 3rd power times 7 to the 0 power. So here you can do it 2 ways now. So same thing as before, when you have the same bases and you're multiplying, technically you can add. And 3 plus 0 is 3. So the answer is 7 to the 3rd power. Another way you can solve it now is 7 to the 3rd power times 7 to the 0 power. 7 to the 0 power just means 1. So then 7 to the 3rd times 1 is just 7 to the 3rd, right? Any number times 1 is the same exact number. So 7 to the 3rd power times 1 is just 7 to the 3rd power. I get the same answer. So here you can use either method. B, I know a lot of you want to be like, oh, shortcut time. All I got to do is add the exponents. But no, it's not as simple as that. You don't have the same bases. Even here, right, you have the 10 squared, and you have the 10 to the 1st, you have the 10 to the 0. Like, oh, well, those are all the same bases. Yeah, that only works when you're multiplying. Unfortunately, what is in between those lovely 10? Not a multiplication symbol, but a plus symbol. I said this before, and I'll say it again. In math, there is a lot more rules when you're adding and subtracting versus multiplying and dividing. Because of those plus symbols there, you cannot do the shortcut. Instead, you have to use PEMDAS, P-E-M-D. First, you do the parentheses. There is no parentheses in letter B, so at least that's done. Now you do the exponents. To be clear, once again, we're actually solving the exponents and not doing any of the shortcuts that we learned because we don't have the same bases and you're not multiplying through. So we have to actually solve the exponents. So we're going to solve 10 squared, solve 10 to the 1st, and solve 10 to the 0. So I'll just write it down left to right. The first number I see is 1. I didn't solve it yet, so it's 1 times. And then instead of 10 squared, I'm going to solve that. 10 to the 2nd power, right? In your calculator, you'll do 10 caret top 2, which you would get 100. Some of you might have known that mentally. Some of you had to use a calculator. So it's 1 now times 100. I'll bring on the plus 2. And then it's going to be times. And then 10 to the 1st power just means 10. Right? Once again, that exponent 1 is invisible, so I can just take it away if I wanted to. Then I'll bring on the plus 3. And then 10 to the 0 power. Any number to the 0 power is always 1. So 10 to the 0 power is also 1. So we times 1. And then I'll take it from there. Now there's no more exponents, so now I move on to multiplying or dividing. So now I'm going to multiply each of these sets. 1 times 100 is 100. Bring down the plus symbol. 2 times 10 is 20. Bring down the plus symbol. And 3 times 1 is, yes, 3. Now there's no more multiplying and dividing. We move on to adding and subtracting. We only have adding next, so we just add. And 100 plus 20 is 120. Bring down the plus 3. And you get 123. Everything that you learned last year, but now you have to also understand that any number to the 0 power is 1. And you got to make sure to convert that number to the 0 power to a 1 right away. And I'm not talking about a 1 exponent, right? I'm not saying the exponent is 1. I'm saying the whole number, so the big number, the base, that turns into a 1. Okay, here, anytime we set up like this, always simplify the numerator and denominator first, and then take it from there. 4 squared times 4 to the 6, right? That's going to be 4 to the 8th. I add the exponents. The 4 to the 8th, I'll just bring down. And then, because you're dividing the same basis, technically you subtract the exponent, that'll be 4 to the 0 power. But then, any number to the 0 power is simply 1, and your answer is 1. And don't forget one basic rule too, right, in math. Whenever you have the same exact number on top as the bottom, doesn't that always mean a whole anyway? Okay, so once again, I would write this as a fraction, and that's just me. You do not have to. Mr. Deegan says you must do it his way. No, listen, you want to solve it this way, solve it this way. I just personally like to write it as a fraction. So this one's going to be kind of weird though. It's going to be a to the 4th over a to the 0 in parentheses, and then times a to the 3rd. So here you're dividing the same basis, so technically I subtract, and it becomes 4 minus 0, which is just 4. So it's a to the 4th times a to the 3rd, and then here I can add, because I'm multiplying the same basis, and it'll be a to the 7th. And there's your answer. You're done. I'm just telling you, you can just see how automatic it is in my head. Whenever I see a division symbol, I write it as a fraction bar right away. Because when the problems get more advanced, more complicated, this is a method that you want to use. All right? Try these on your own. Please don't forget, if you don't see an exponent, to put a 1 there, and we'll move on to part B. Okay, part B. For any non-zero real number, a, and any integer n. Let's just say it was 5 to the negative 2 power. A lot of times I get, the answer is negative 25. Yeah, you're wrong. So the first thing I want to have you do is, with the calculator, get the answer. Right? So you're going to do 5, caret top, negative 2. And plug that in. 0.04. So what does that mean? Please understand, a negative exponent doesn't mean that the answer is negative. It just means the answer is very tiny, right? So 5 to the negative 2 power ends up being like 4 cents, if you want to think of money. So it's not that a lot. It's not that the answer is negative, but it's not really a lot of money either, right? So a negative exponent just means that the value itself is small. So how can we get that answer without a calculator? And before I even explain that, I know some of you are like, well, why do we even care? We have a calculator. Yeah, but what happens if it's x to the negative 2 power? Then you're not going to have a calculator to help you with that, because you can't put x in the calculator. Well, let's learn how to do it with and without a calculator. So with a calculator is pretty straightforward. Without a calculator now, right? 5 to the negative 2 power. So whenever you're dealing with negative exponents, you should always think of fractions. It's easier to solve with a fraction. So the first thing I do when I see a negative exponent, the very first thing I do is I make the base into a fraction. So now it's 5 to negative 2 power over 1, right? I can make any number into a fraction if I put it over 1. Now this is the part that gets kind of confusing. And I'll do my best to explain it. In order for you to convert the negative exponent to a positive exponent, you have to move it to the other side of the fraction bar. So for example here, if I take this 5 to the negative 2 power, you see how it's on top? Do you see how it's in the numerator? If I brought it down to the denominator, the exponent turns into a positive. Once again, if I take the negative exponent and I move it to the opposite side of the fraction, so obviously if it's originally on top, I need to move it to the bottom. However, if it's originally on the bottom, I would then have to move it on top. So the key is not, you have to move it always on the bottom. No. The key is you have to move it to the opposite side of the fraction. Once again, because this number was on top, if I move it down, the exponent turns positive. And it is 10 times easier to solve a positive exponent than a negative exponent. So now I'm going to solve it from here. Now on top, I have no number now, right? It's blank. So in algebra, in math, whenever there's no numbers, you got to put that invisible number. And that invisible number is 1. So on top, because there's no number now, you put a 1. On the bottom, it's really 5 squared. And then don't forget this times 1. So do PEMDAS. 5 squared is 25. And then 25 times 1 is still 25. And there's my answer. Now I know what you're thinking. Well, with a calculator we got this, but you got that. Yeah, well, convert the fraction to a decimal now. Do 1 divided by 25, and you will get 0.04. Understand that this is the better answer. It's better to leave it as a fraction. So 1 over 25 is your answer. What you should get out of this is you convert your negative exponents to positive exponents. You do that by moving the negative exponent to the other side of the fraction. But make sure you also bring with it its base. All right, so this one is 13, negative 4 times 13, 7. So here, this one, there's actually 2 ways of solving it. But in letter B and letter C, there's only one way of solving it. I'll show you the easy way first, but this one only works for letter A. So this one you can just do what you did in lesson 1.1. When you're multiplying the same bases, technically you can add the exponents. And negative 4 plus 7 is positive 3. My answer is 13 to the 3rd power. And you're done. Once again, this example, you can do this. This is fine. Whenever I see a negative exponent, I already start thinking to myself that I want a fraction. So I do a fraction bar here. You can put the 1 here if you want, but you don't have to, right? Once again, the 1 could be invisible. So I think for a lot of you, I wouldn't even put the 1. My next step would be I would convert the negative exponent to positive exponent. So you see how you have the 13 negative 4? I don't want to deal with negative 4. I want to deal with a positive 4. It is easier to deal with positive exponents than negative. So I'm going to take this 13 negative 4 and I'm going to bring it to the other side of the fraction. When I do that, that negative 4 now turns to positive 4. And now I'm solving 13 to the 7th power over 13 to the 4th power. And then when I solve that, when I divide the same bases, technically I subtract the exponents. And 7 minus 4 is 3. And my answer is still 13 to the 3rd power. So when I do x to the negative 7 over x to the 4th, once again, my goal is to convert any negative exponents to a positive. I do that by creating a fraction bar. The good news with letter B is, didn't they already give us a fraction bar? So you don't even have to create one, they gave it to us. All I'm going to do is this. Think of like a class right now, right? If I have a student who's acting negative, right? It might get to a point where they're disrupting the class, and I'm going to move them somewhere else to hopefully change their behavior. It's kind of like that here as well. I'm going to take this negative exponent. I'm not going to leave them the way it is. I'm going to move it. And by moving it to the other side of the fraction, the negative exponent is now a positive exponent. Now, the only tricky thing with this one is, in math, you cannot have a blank numerator. Denominator is okay. If you have 5 over 1, you can just say 5, call it a day. But you can't have blank over 5, right? There always has to be a number on top, always. So if there's no number on top, you got to give it that invisible 1. So now it's 1 over x to the 4th, x to the 7th. But then you solve it from there. Bring the 1 over. And here there's multiplication in between the two x's. And technically when you multiply the same bases, you add the exponents. And 4 plus 7 is 11. So my answer is 1 over x to the 11th power. Once again, I see a division symbol. Fraction bar right away. 9m is on top, and 3m to the negative 2 power is on the bottom. Whenever I see a negative exponent, right away in my head, I have to create a fraction bar. So step 1 is done. Step 2, convert any negative exponent to a positive exponent. They think, once again, because you have the negative 2 on the bottom, hey, let's move it on top. And they're wrong. You are going to move something on top, But you're not moving the 3 and the m. You're just moving the m. Once again, without parentheses, the exponent is only attached to the closest base. It is not attached to any other bases. So I am moving just the m and the -2 up. And the 3 stays behind. I'm going to expand my fraction bar. And once again, that -2 now turns into +2, which is awesome. And now I can solve it normally. The first m doesn't have an exponent, so I'm going to give it a 1. And then I'm going to solve from there. Fraction bar here, and m to the first times m to the second. Technically, I add the exponent, and it's m to the third. Now I'll solve this. Remember, these are not exponents. These are coefficient numbers. These are big numbers. The font is huge. You do not use the exponent laws on coefficient numbers. There you just literally do what it says. It says 9 divided by 3. And what is 9 divided by 3? 3. And you're done. My answer is 3m to the third. Please understand that the 3 is on top because 9 had more players than the 3 on the bottom. Alright, try these on your own and call me over if you have any questions.